Wanted to record a short video that looks at Scikit-learn's OneHotEncoder versus Scikit-learn's dictionary vectorizer and why I prefer to use the dictionary vectorizer. So I've come up with some sample data here, a training data set and a test data set. We actually will not run any models on this. We are just going to do some pre-processing and transforming. And I have a few columns actually commented out that I will put back in later, but right now we just have breed and hair. So we can see in our training data we have cats and dogs. For hair we have short, medium, and long. But in our test data set we have cat, dog, and we have fish. So that does not appear in our training data. And for hair, we have short, long, we don't have medium, and we have unknown. So let's see what happens when we use Scikit-learn's OneHotEncoder for that. So I instantiate it here. I do a fit transform on the training data. I print out the training data. This here will ensure that I get back a pandas data frame, which will be easier to inspect. And then here I transform the X test, so I have fit it on the training data, and then I'm transforming on the test data. So let's see what happens. And if we look at this, it really all looks good. I will mostly just look at the testing data because that's what we're really interested in, is with these different categories what actually happened to those. So we can see that our third row here has 0 for cat, 0 for dog, and 0 for hair, long, medium, and short. So that actually kind of did what we wanted. There were no issues, there were no errors thrown, and that was because we passed in this argument handle unknown as ignore. So that just ignored these categories that it had not seen before. So one thing that I want to do is I want to uncomment this age column. Let's rerun this and see what happens. Oh, so by default, the OneHotEncoder interprets everything as a category and dummy coded those. So that's probably not the default behavior that we want. However, that is something that we can certainly overcome, right? We can use a scikit-learn pipeline for that. I'll include a link to this example, but you could do something along the lines of a column transformer. So you could grab your categorical columns and then make sure that you just pass those to the OneHotEncoder. So there are ways around that, although it may not necessarily be the most defensive in certain situations. Let's go ahead and take that back out. I then want to add a category to this. So let's say that in my test data, I have a new column that has appeared. So, this is not something that we would necessarily design, but this is something that we potentially want to account for when we're writing defensive code, is maybe, hey, something goes wrong with the test data set, or maybe when we're in production, something weird happens and a piece of pre-processing code creates a new column. This could happen when we're running a loop or something along those lines. So let's see what happens here. Oh boy, we actually error out feature names unseen at fit time food. So this actually caused an error. Let's take that back out and then let's move around our column order. So in our training data, we have breed followed by hair. And in our testing data, we have hair followed by breed. And we get another error. Feature names must be in the same order as they were in fit. So we can see that our OneHotEncoder definitely works if we make sure that everything is aligned here. So we have breed and then hair, even if we have these new columns, or pardon me, these new categorical levels that then turn into dummy columns, or they would not get turned into dummy columns. Let me word that properly. So these categorical levels get handled correctly in the fact that we did not want those to turn into new dummy columns. So we can see that, yeah, this works, but it's maybe not the most defensive, and it could be a little bit brittle based on these examples. And so there are ways to definitely fix this, right? So we can anticipate what the schema is during training, and then in production, we can take that frozen schema and make sure that our incoming data adheres to it. So that is absolutely something that can be done. That's something that I've done with certain types of projects in the past based on the type of pre-processing that was needed. But it can be a little bit brittle, and it introduces another opportunity for error. So let's comment out this code. And then let's look at the DictVectorizer. So this is something that I like a little bit better than the OneHotEncoder because it is less brittle, and you can kind of use it to be defensive and handle some issues that might happen with your upstream data. So again, these are not issues that we would necessarily anticipate happening, but if issues do happen, we want to plan for those and write code that will still work even in the face of maybe upstream data changing a little bit. So there is one custom transformer that we need. We need to take our data frame and convert it into a set of dictionaries, basically. So we can create our own transformer here. I've called it features to dict, and we can see what that looks like here momentarily. Actually, I'll go ahead and run that so you can see what that looks like. So this turns our data frame into a list of dictionaries. Again, this is a necessary pre-processing step. We then instantiate the DictVectorizer. By default, this will give us a sparse matrix. However, for visualization purposes, we want to turn this into a dense result. It just makes it a little bit easier, again, to inspect visually. We will fit and transform the DictVectorizer on our X-training data set. We can use this method attached to the DictVectorizer to get the columns. We'll print that out. We will then convert the features to dict. We'll then run features to dict on the X test, and then we will transform X test using our fitted DictVectorizer. Now here, we just run fit transform because technically this is a static method. I probably should put a decorator here, but there's no fit step here. We're just doing a straight transform. So just, for convention, we call fit transform here as well. All right, let's run this. And we can see that, okay, we have our dummy variables here. And we can see that, okay, with the third row of data in our test set, which again had fish and unknown, no dummy variables were created. This handled this exactly like the OneHotEncoder, which is what we wanted. Our model would not have learned anything about those dummy variables. So in this case, we just want to drop them. Let's see what happens if I add in age to my data frame. Oh, that actually just handles it. It identified that this was, in this case, an integer, and it did not dummy code it. That is pretty nice default behavior. Again, we can use something like a column transformer with the OneHotEncoder, but we don't necessarily need that with the DictVectorizer. Let's add the food column to the DictVectorizer. That did not throw an error. So if you remember with the OneHotEncoder, when we added a new column, it freaked out. In this case, it's basically giving the equivalent of saying, hey, on the training data, I did not see a column called food. Therefore a subsequent model will not be able to learn anything about that column, and I'm just going to ignore that. That's nice defensive behavior. That's a little bit less brittle. Let's then also reorder our columns. So here with our training set, when we're doing the fit and transform, we have breed followed by hair. Now we have hair followed by breed. And yep, that did not error out on us. We still get the correct dummy coding of variables. So we can again see that our first row is a cat, our second row is a dog. Then we have hair short, and then there's no medium hair, and then hair long for this second row here when it's a dog. So yeah, that is nice defensive behavior, and it is still a good idea to do checks on incoming data when you're running in production, and making sure that everything looks like you want. But this is a nice way that's a little bit less brittle than the OneHotEncoder, and it's a little bit more defensive, and it just does the same thing under the hood, but it has these nice properties of just again being a little bit more robust. So one other thing I wanted to show with the DictVectorizer is that you can then do subsequent transforms on the output of this. So we're going to come up with another sample data set. We'll have nxtrain, we'll instantiate the DictVectorizer, we'll do a fit transform, and then after that, we are going to run a simple imputer, so this will just impute the mean. So this last value here is a nan, so we can see that. Oh, I forgot to run the features to dict on this. So this is the one thing that you have to make sure you do. You have to make sure that you convert your data set to a list of dictionaries, and then it will work. So it's not a totally free lunch, as you need to make sure you do this transformation step, which I forgot to do. But we can see that, yep, it imputed that last value with a 7, so you can run subsequent transformers after the features to dict. After running features to dict and then DictVectorizer. And I've alluded to this in the past, is you can run a DictVectorizer in a scikit-learn pipeline like so. So we can see that we run that here. I actually ran it also on my numeric data. So this does a column transformer. So this grabs my numeric variables, this grabs my categorical variables, and then does a separate pipeline for each one of those. And the reason that I actually just do this here is so that I can grab the column names before they kind of get lost in these NumPy arrays that get put out here. But this can be easily put into a scikit-learn pipeline for easy deployment. So this is why I like the DictVectorizer. Again, it's not a get-out-of-jail-free card. You still want to do checks in production on incoming data and do validation. But this is a more defensive, more robust way than the OneHotEncoder, and therefore I like to use it because I just like to be as defensive as possible in my code to make sure that my models can always return predictions that I am confident in. So hope you enjoyed this video, and I hope that you use scikit-learn's dictionary vectorizer.